This is example 6 from the Solving Rational Equations lab. We have the following two functions, f of x and g of x, and we want to find the point of intersection if one exists between the two functions. So a point of intersection is when these two graphs equal one another. They have the same y value. So we can write that as f of x is equal to g of x by using what they are equal to. So we have 2x minus 3 over x minus 3 minus 2 is equal to g of x, 12 over x plus 3. And now we have our rational equation that we want to solve for x, but before we do so, we need to know what x cannot be. We know that when we divide by a 0, it's undefined, so our denominators here cannot be equal to 0. So for x minus 3, if this cannot be 0, then x cannot be positive 3. And if x plus 3 cannot be 0, then x cannot be negative 3. So those are the two scenarios where we cannot have those particular x values, our domain restrictions. So next we're going to find the LCD, the least common denominator of these fractions. So we have x minus 3 and x plus 3. Those have no factors in common. So it's just going to be those two denominators multiplied by each other. And we're going to take this LCD and multiply it to this entire equation on both sides. So, writing that out, we have x minus 3, x plus 3, times the left side of our equation, which was f of x, which was 2x minus 3 over x minus 3 minus 2. And the right side of the equation, which was 12 divided by x plus 3, multiplied by our LCD, which was x minus 3, x plus 3, like that. So multiplying through, we have these two terms that this needs to distribute to. So for this first term, 2x minus 3 over x minus 3, we note that once we multiply this through, we'd have an x minus 3 and an x minus 3 on the top and the bottom, so those would cancel. So we're just left with 2x minus 3 times x plus 3. So we have 2x minus 3 times x plus 3. This second term, this negative 2, nothing will cancel. So we're just going to write it as negative 2 times x minus 3 times x plus 3. For the right term, we have x plus 3 on the top and x plus 3 on the bottom, so those will cancel. So we're left with just 12 times x minus 3. So now moving on, we need to continue our distribution and our multiplication. So for this term, we have 2x squared. So multiply that 2x by x. We have 2x times positive 3, so that's plus 6x. We have this negative 3 times x, which is negative 3x. And then finally, the 3's multiply together, so it's negative 9. So I'm going to multiply these two, this x minus 3 and x plus 3, before we multiply the 2 through. So this is minus 2 times, we got the two x's multiplied, so we have x squared. We have plus 3x. We have minus 3x. And we have minus 9. And for the right side, we have 12x minus 36. So what I'm going to notice first is this plus 3x minus 3x will cancel to 0, like that. And we have this 6x minus 3x. That is just going to be 3x. So we're going to write this as 2x squared plus 3x minus 9. We're going to distribute this 2 through. So we have minus 2x squared. Then this is just 0, so we have negative 2 times negative 9, which is positive 18, is equal to the right side, 12x minus 36. So I'm going to move the normal numbers to the right and the x squares to the left, because this 2x squared minus 2x squared will cancel to 0. So there's going to be limited factoring involved. There's only going to be one answer for x. So we have 3x And so we're going to subtract 12x to get the 12x to this side. So it's minus 12x. And then I'm going to move this 9 and 18 to this side. But if we notice, positive 18 minus 9 is just 9. So we're going to subtract 9 on each side. So negative 36 minus 9 is negative 45. So 3x minus 12x is negative 9x equals negative 45. So dividing by negative 9 on both sides, we have x is equal to 5. And we go back to look at our domain restrictions to make sure that we can have x equals 5. And we notice that x cannot be 3 or x cannot be negative 3. So our x equals 5 is legitimate. Now what we're going to do next is we're going to find the actual point of intersection. Right now we just have the x value of our point, but we need to write a point of intersection in this format where we have an x value and a y value. So we need to find the y value, and so we're going to take our x equals 5 and substitute it into either f of x or g of x to find the y value. They'll be the same because it's a point of intersection. They have the same y value. So looking at which one is simpler, I'm going to choose g of x to substitute our x equals 5 into. So we have g of x is equal to 12 over x plus 3. And we had a x value at the point of intersection of x equals 5. So substituting, we have g of 5 is equal to 12 over 5 plus 3. That's 12 over 8. And these have a common factor of 4. So taking the 4 out of 8, we have 2. And taking the 4 out of 12, we have 3. So this is equal to 3 halves. So and this is our y value. So we have a point of intersection of f of x and g of x at 5, 3 over 2.